Hello, my name is Colin Campbell, and this is my introduction to machine learning for my Berkeley blockchain class, and this is my first use case. The problem statement I'm trying to focus on is how do we stop global warming and make the energy grid more resilient by incentivizing companies, government, and people towards sustainability. The solution is to build an energy grid using blockchain, issuing blockchain tokens on smart meters for houses, companies, and power plants will identify the type of energy and creation time. An exchange would allow for the buying of energy from the source and choosing the type of energy. The value of green energy, solar, would be slightly higher than that of dirty energy, coal. In time, energy costs would be reduced to be less than that of fossil fuels. The goal for machine learning is provide automated incentives to people to purchase the different type of energy in the exchange. And I got a couple of picture slides at the bottom. There's Mayor Eric Garcetti's Green New Deal. LADWP is doing a feed-in tariff program, which is trying to incentivize renewable energy, as well as decarbonization for Southern California Edison is a high priority by 2045. They want to have zero carbon footprint. And then there's the Department of Defense, which is Project Jedi. So combining all these things, this example right here is from machine learning for supervised versus unsupervised models. These two are the most simplest ones. I grabbed them from my machine learning class. These are their slides, but I have the most simplest one is regression. How many will there be? So we have the number of bedrooms. You also have this house is by the bay. You have the location, and you can predict approximately what the house price is for regression. Now, classification is where you have data coming in, and you're trying to say, is this A or is this B? So for spam filters, emails are coming in. You want to basically say, is this spam or is this not spam? So unsupervised models, one example is clustering, is where you actually don't go and set up the data and you're not really looking at it much. It's just running and looking at the metadata as well as the actual data. And it takes the customer, it does the model, and it creates customer segments. This is segment A, this is segment B. In this example right here, you have the age of the person, and then you have reward incentive A or B. And then you would run the information through, and it would say, this is group A, this is group B, this is group C, group D. And my action plan for the clustering model is collect data. First is let's collect the energy source data. Using blockchain, you could get the energy type, the source, location, where it's from, and the time it was created. And then you could grab customer data, which is from Southern California Edison's customer master or Department of Water and Power's customer master, and you merge it all together. You would create the exchange data where people could put in their customer preferences. I would like to be rewarded for this if I do this. And then for environmental data, you could also combine the EPA, city, and state incentive programs. So machine learning clustering model is the one that we'd use for this data capture system, as well as it would do a payout. So it would cluster the people into segments based on common traits. Then it would create a segment of different types for people to offer different incentives. In this case, some people would get Tron, some people may want Bitcoin, some people may want just cold hard cash, USD. Some people may want a stable coin, which is USDC. It's one-to-one with the US dollar. So the anticipated changes or results. Data scientists will need to review the progression and adjust the action plans and targets. They would need to set an action based on preferences. They have to go put that in there. They have to refine the criteria of the incentives to motivate change. And then they would also need to be able to refine the populations by doing behavioral analysis for target audiences. You could bring in demographic data and location data. And the results, this is just mocked up, and I took the data from my Berkeley class, but I'm trying to put it out here is you have your age are there. And so the older populations I'm expecting would probably want to be paid out in US dollar. They want money, cash, regular stuff. But some of them who want something a little bit more different, related to cryptocurrency, may want USDC, which is one-to-one US dollar. Now, the younger populations may want different coins based on their preferences and their buying habits. So younger people maybe who want incentive A may want Tron. And then younger people who are more professionally based may want Bitcoin. So my recommendation is let's create machine learning clustering models to create target segments for accounts, citizens, to present actionable incentives to drive them to choose what type of energy they want to use. There are many different machine learning models out there. There's classification, there's regression, there are many of them. We can use them to refine and tune communication and incentivize of marketing applications for utilities. Targeting customers to know who they are and what they want is essential. Customer profile preferences can be used to choose the type of energy and rules. So in conclusion, I recommend a new blockchain platform which utilities such as Southern California Edison should invest in energy exchange using blockchain and machine learning, and then enabling machine learning to know the customer base and automate incentive payouts based on customer profiles. Thank you for your time. I'm Colin Campbell. Have a good day.